Good morning, students. Today we are going to read the second lecture, that is methods of magnetization and demagnetization in the topic of laws of magnetism and magnetic properties of the matter. So concentrate yourself. We are going to start. The first thing that we are going to read is the magnetization. A magnetic material can become a permanent magnet by using stroking and electrical methods. The first method that we are going to read is magnetization by stroking method. So concentrate yourself, we are going to start. The following diagram shows how permanent magnets are used to magnetize a steel bar. In both cases, the steel bar must be stroked several times using the same pole of the permanent magnet. For example, the north pole of a permanent magnet will be stroked again and again like this, like this again, and this should be several times done, and then this steel bar will become the permanent magnet. Or here is another way, that is also a stroking method by taking two magnets are in our hand like this, that opposite poles should be struck with the steel bar like this, so this should be done several times. So when we will do this thing several times by stroking one permanent magnet with the steel bar, or by stroking two permanent magnets, but opposite poles should be struck in this way. So the steel bar will become the magnet. Here is an exam tip for you people. The pole produced at the end of the steel bar where the strokes finish will have the opposite polarity to that of the end of the magnet in contact with it. So when the single magnet is stroked, so look now, if this is north pole, so if this is going in this direction, so south pole will be created here. And when two magnets with opposite poles are struck like this, so north pole is moving in this direction, so south pole will be created here, and south pole is struck in this direction, so that's why north pole will be created here. The second method that we are going to read of magnetization is by electrical method. So concentrate yourself. A solenoid. A solenoid is a cylindrical coil of insulated copper wire. So this is actually a cylindrical insulated copper wire, that is called solenoid. Is connected to DC supply. So look now, it is connected to DC supply. A steel bar is placed inside this solenoid. So a steel bar is placed inside this solenoid, and the direct current is passed for a while. So the direct current is passing now. A strong magnetic field is produced and the steel bar is magnetized. When viewed from any one end of solenoid, if the current flows in clockwise direction, this end is the induced south pole, and if the current flows in an anti-clockwise direction, this end is the induced north pole. So this will be explained here. So look now, if the direct current is clockwise, so look now, this is clockwise, this end will become the south pole, and if the current will be anti-clockwise, so then that end will be anti-clockwise, north pole. Another thing that is very important for deciding the north and south pole, this is called right hand rule. By gripping the solenoid with the right hand such that the fingers are in the direction of the current in the solenoid, so whatever the direction of the current is, grip the rod or the thing that is magnetized with the right hand in such a way that the fingers are in the direction of the current in the solenoid. The end of the magnetized steel bar that the thumb points to is an north pole. So your thumb will point the north pole. This is called right hand rule. Here is an exam tip for you people. Electrical method is the best method to make powerful magnets. The magnetized steel bar is now called an electromagnet. So this is very important point to be noted, because this question normally comes in paper number 1 in MCQs. So the magnet which is produced by the method of electrical method, that is called electromagnet, and this magnetized steel bar is now called electromagnet, and this is the most powerful method. And now we are going to read the demagnetization methods. The first method that we are going to read is by AC current in solenoid. So the same thing will be done, but this time the current will be AC. So then the steel bar will be demagnetized. So look now, the solenoid is connected to an AC supply. A magnet to be demagnetized is placed inside the solenoid parallel to east-west direction. So this is east-west direction. So the steel bar will be placed east-west direction inside the solenoid. Following the east-west direction, slowly withdraw a magnet far away through the solenoid while the AC current is still flowing. So move the magnetized material in this direction, east-west direction, several times. After doing this several times, the thing will be demagnetized. As this process is repeated, the magnet will be demagnetized. This is the most efficient method of demagnetization. The next method that we are going to read to demagnetize a magnet are by heating and hammering. So look now, if we heat a magnet with a strong Bunsen flame until it is red hot, the magnet will lose its magnetism very quickly. This is due to the increased vibration of the atoms of the magnet. So this is the reason why the magnet gets demagnetized, because when the magnet is put into red hot flame, the atoms get more vibrate, they move more speedily, atoms of the magnet, which cause the tiny magnets to lose their alignment. So their alignment is disturbed. That's why the magnetism is destroyed. The next method that we are going to read of demagnetization is by hammering. So look now, if the magnet is hammered vigorously while lying in an east-west direction, its magnetism will become weaker and weaker. As in the case of the heating, hammering also causes the tiny magnets to lose their alignment, causing the magnet to lose its magnetism. Here is another very important small topic in the lecture, that is magnetic screening. Some electronic equipment is easily upset by magnetic fields from nearby generators, motors, transformers, or the earth. The equipment can be screened, that is called shielded, by enclosing it in a layer of a soft magnetic material such as iron or nickel. So the magnetism can be preserved by enclosing it in a layer of the soft magnetic material such as iron or nickel. This redirects the field so that it does not pass through the equipment. That's why the magnetism is preserved. This process is called magnetic screening or shielded. Here is another very important topic that frequently come in the paper. That is the difference between the magnetized material and demagnetized material. So concentrate yourself. On the left hand side, magnetized, on the right hand side, demagnetized material. When a magnetized or unmagnetized material is subjected to magnetization, all the molecular magnets in all the domains will then be approximately forced to orientate in one direction, as shown below. The arrowheads signify the north-seeking poles. So when an object get magnetized, so it is aligned. Okay, the second thing is the domain theory of the magnetism suggests that the presence of the molecular magnets is due to the spinning of inner electrons about their axis. Their molecular magnets are contained in very small volumes known as domains. Within each domain, the molecular magnets are all oriented in one direction. However, in an unmagnetized material, the molecular magnets in the neighboring domains are randomly oriented, thus producing no net magnetism, and the alignment gets disturbed. As diagram shown below, the overhead signify the north-seeking poles, so the alignment gets disturbed. Arrangement of the molecular magnets within the domain in an magnetized material. Okay, a piece of the soft iron under the influence of a magnetizing force will immediately revert to the demagnetized state when the magnetizing force is removed. So this is the thing, because soft iron is a temporary magnet. So as far as we remove the permanent magnet, its magnetism is finished. However, in certain alloys like Alnico, which is commonly used to make permanent magnet, the magnetized state of the affairs remains for a long time after the magnetizing force is removed. In fact, some of the domain walls of the Alnico disappears in the magnetized state. So the first difference is in magnetized and unmagnetized material is, in magnetized material, the all magnets arrangement of the molecular magnets within the domain is in a demagnetized material, the arrangement gets disturbed, whereas in magnetized material they are aligned in one direction. So this is the one difference. The second difference is magnetized materials possesses magnetic properties, whereas the demagnetized materials do not possess magnetic properties, but with magnetization it can become a permanent magnet again. So these are two major differences between magnetized and demagnetized materials. So this was the lecture, students. I hope so it will be much easier and interesting for you people to understand. So read this lecture again, understand it, learn it, and make your notes. Thank you so much.